In this lecture, we will see what is a metacenter. You can see here a vessel. In vessel's center of buoyancy is B. It is floating. Center of gravity is here G. You need to find the metacenter. When this vessel is tilted, the center of buoyancy will be shifted rightward. And a force will be acting through this center of buoyancy, through this new center of buoyancy upward. And center of gravity will remain same. Center of buoyancy will be shifted rightward. So if you draw a line through here, it will meet the earlier vertical axis at a point, and this is called metacenter. So metacenter is defined as a point about which the imaginary axis drawn through the new center of buoyancy will meet the vertical line passing through center of gravity and old center of buoyancy. And here the metacentric height is gm. Now how will you find the metacentric height? See, metacentric height is found using the formula I by V minus Bg. See, I is the area moment of inertia and V is the volume of fluid displaced and Bg is the distance between center of gravity and center of pressure. So if you take a fluid like this and this is your body. So if you draw the top view of this body, it will be something like this. The view from the top. Okay. So in order to calculate the metacenter, or metacentric height, that is gm. This is the new center of buoyancy B dash. This is m. So this is gm. That is distance between center of gravity and metacenter. So gm is equal to I by V minus Bg. So here it is B. This is center of buoyancy. Bg is the distance between center of buoyancy and center of gravity. And volume is the amount of water displaced. That is volume of fluid displaced. So that is this much volume. And I is the area moment of inertia about this axis when you view from the top. So here this height may be h and width is b. So this will be b. And the top view, you can see that this may be the L, that is length of this body. That is the top view. So here area moment of inertia is equal to LB cube by 12 because you are finding the area moment of inertia about this axis. That is LB cube by 12. So this is how you calculate the metacentric height.